Okay, the final example for this one says that we have a waterfall that the waterfall is a height of 100 meters and we have a flow of 1,000 kilograms per second. So 1,000 kilograms of water is quite a bit. How much energy is produced in 1 hour? So would be the things like the Hoover Dam, and the water falls over the dam, turns a turbine, produces electricity. It's another example of the conservation of energy. What we were trying to figure out is the energy that is produced. So I'm just going to go ahead and say that it's potential energy right now. It could be work, it could be anything that we've talked about so far, but since this is potential energy, I've got a clue that it's going to be that. Now I also have potential energy is equal to mass, gravity, height. So what I have is 1,000 kilograms of water per second that flows over this waterfall that's 100 meters tall. So this may be confusing for some people because you've never seen kilograms per second, but it does say how much energy is produced in 1 hour. So you have a time, and that time value is 1 hour, which is 3,600 seconds. You should know that conversion by now. So if you have 1,000 kilograms every second, and you're doing it for 3,600 seconds, you should realize that just by multiplying those two together, you are going to get the total mass of water that goes over the cliff as being 3,600 times 1,000, which is 3,600,000 kilograms of water. Now you know that gravity, all the waterfalls that we know of are on Earth, so we know that the gravity is 9.8 meters per second squared, and we know that the height is 100 meters. So that allows us to figure out, we say potential energy due to gravity is going to equal 3,600,000 times 9.8 times 100. When you do this calculation, you get 3,600,000 times 9.8 times 100, or 352,800,000 joules of energy. So 3,528,000,000 joules of energy, which is quite a bit from this waterfall.